Hello everyone. I guess few more are joining. I can see request. So just confirm me through chat box. Am I audible? Is it? Yeah. Check, check. Am I audible now? Thank you, thank you, thank you all. Yeah, let's get started. Yeah, I have opened this session to join anyone. People are joining. So today our regular class, MLOps fundamentals. Okay, MLOps fundamentals. So why I would like to teach you the fundamentals means before we get into any deep discussion of this AIML or any cloud platform or this training, all these things. So we should understand some basic things because I know that here if you are different domain, which is these terminologies are very new to you. So to avoid that confusion and all, so we will start from the scratch. We'll understand first the software thing, and we'll understand some application things, and then protocol things and server things, and then we'll go for gradually like that in deep. So before I mention like MLOps fundamentals, what are all prerequisites that I need? So before I should understand this fundamental, what kind of knowledge I should hold? Yes, I know we are all already professionals, right? We are means all are working professionals. We know at least something, right? So we know software is, we know software lifecycle, how it will work. We know that what are the applications and how the application will be working. So to just give you a recap, I'll be again giving you same kind of explanation. So just bear with me for 5 minutes and then we'll go like that step by step. So first of all, who are learning this? You might be on a support side, you might be on a testing side, you might be on a network engineer, you might be a cloud engineer, or I even talk with many other people. They are like data analytics side, and if you are um, just application support, only chat support, application support also there. So for them, how can I make to understand of this all terminologies? So we need to understand how the flow works, first of all. So in the software thing, we call it as industry, right? We call it as industry. Like you can take a physical industry. Okay, so physical industry like a soap manufacturing company, like let's say in India we have Santur soap and all, right? You take any product, any physical product. If you take any physical product, the product will be ready by with some raw material, right? So we will be collecting some raw material. What this raw material? This raw material could be a crude oil, which we are usually collect from the seas, oceans, right? Or from somewhere else, from the trees or somewhere. And then we will do a certain kind of a process to it. We will do a certain kind of process to it. What process? Heating and adding some other chemical components to it, and then cooling. And again, we will be heating that. And then again, we will do some process. And then it will be converted as a final product. Okay. Then it will be converted as a final product. You take this life cycle everywhere in the industry. So we are calling as a physical industries, which is car manufacturing industry, or tire manufacturing, MRF and all. So every industry you take, so those are mechanical missions are there. Our software industry also inspired from the same engineering. There is no difference. It is also inspired from the same engineering, what we are doing at the mechanical side, the machinery development side. So we are also building the machineries and everything, right? Similar way, this software industry also is inspired from the same core fundamental pillars, and it is also designed. Okay. If I talk about the software side, so this final product, if you are thinking like is um, a bathing soap, then think like a software application, application like Netflix or Zomato, or you take any application. Okay, you take then any application. So this application is the final product actually. So to develop this final product, we have to also go through all these phases, whatever in physical industry that we are going through the phases. Okay, if I ask like soap manufacturing company a process. So if I ask the images, I'll get some images here. So you can see, let me take this one or this one. I'm just giving you an idea. If you see here, what happening at the end, there's a product. At the end, there's a product. So to get this product, we have to follow all the steps, all this. So this is called, and again, this product is need to be do anything, any modifications by taking a review or a feedback, and we will do again some sort of changes to attract the users. So that is entirely you can call it as a life cycle. Okay, so we have to cross all these phases of the life cycle to generate this product in a physical software also same. There's no difference, but the terminologies are different, but the connectivity is a little bit different. We call integrations. Here we call connecting the machineries. When I take any raw material, first I'll put it into here. I'll heat, I'll process something, and then I'll do this process, adding colors, perfume, builders, and then I'll do cooling, then I'll do cutting, drying. So this like this. Finally, the shipment will be happen. So here the product will be delivered to the customers. Okay. Here, this is going to deliver to the customers. Now, think this as a Netflix, okay, application. You need to follow the same steps again to the Netflix also. Same. What we will be doing here as part of this software side, software side, we will plan about this application based on the business. How you are planning to your soap product as a plan that you wanted to deliver to the customers. Similar way, you also do a plan for your application. And then there is a life cycle called DevOps life cycle. So this is a DevOps life cycle. So this DevOps life cycle will be very, very important in this case. Similar way. Uh, what happens here? So here we will be doing a plan here about the product, and then developers will do a code, and then after it will build, and then we will do test and release, deploy, operate. So in the deploy, this is where you're deploying into the Play Store, okay, or your App Store. And as you are a user here, you are accessing this application, and anything that you are giving, something is not working, you have given some feedbacks, they will be collecting these feedbacks. Or is there any bug found? Then automatically, while they are operating this application, so when you have deployed this, this version is called something like v1.1.0, okay, or 12, like this. And in this version, you given some feedbacks. Many users are giving some feedbacks in the Play Store that this is not working properly, or there are some bugs and all. Immediately while you're operating, your engineering team is operating, your observability team is operating. So that time they will collect all your feedbacks, and then they again go for the planning mode. So this is where we call hot fix and bug fix while this application is running inside the production. So this is about the applications. This is about the applications. And once they have planned, again they repeat the same cycle: code, build, test, release, deploy, operate. Same. On top of this same life cycle and the same pillars of the DevOps, MLOps is built. MLOps is built because where this MLOps will be working, where this MLOps should work, ultimately in your application only. In your application only. Here we have deployed Netflix, right? In Netflix, there are many models are running actually behind. So there are more than 10 plus, 20 plus models are running behind the scene. The Netflix, whatever every day you are using. In Amazon, there are 100 plus models are running actually. So every day the model is deciding your behavior inside the application. So if you ask, this application is actually managed by the DevOps engineers, and inside there is a model will work. There is a model will work. So that model is also part of this DevOps and including same principles, same workflow and all. Okay. So let me give you more clear picture and how this is built and how this terminologies we can remember in our brain. So every time should not confuse that. Okay. I know this platform is running this life cycle. Okay. A simple thing here in the above case, in the above case, I have all these missionaries, right? So this is my product and software application. Okay, this is my software application and this is a physical product. Here you are doing some heating. Here doing something. So this is a missionary, right? So these are all missions. So this is a mission. This is a mission, and this is a mission. So in this cycle, this mission is using for your product, but in our software, this mission is nothing but a tool. This mission is nothing but a tool. Which tool? Let's say it is a Git. And then here there's a one more tool. Which tool? It is a build tool. Okay. And this is another tool like testing tool. And this is a artifact tool. Like this, you can assume like that. Okay. So these are all the tools. You can just replace machine with the tools. Okay. And where all these tools are placed in a platform. Where? In a platform. Which platform? On a land. So you will be building one shelter, right, for it. And under in this shelter, you will keep all these missionaries, right? So this shelter is nothing but your cloud, AWS, Azure, or GCP, whatever. So on top of this platform, you are developing your own. Your shelter means your own networking, IaaS. Here you can call it like this. Inside that your shelter, you are keeping all these missionaries and you're connecting one to another. You're connecting one to another. When you're connecting one mission to another mission, this is called integration. This is called integration. So these are all terminologies, very simple. When you're connecting one tool to another tool, called integration. So you're placing all them together, okay? And you define a flow. So this should become like this. You're defining a flow like this, right? So this flow called pipeline. This flow called pipeline. So this is technical terminologies. So this pipeline will tell you that, so this is a source and this is the destination. By connecting your missions, your tools. So you can define this pipeline however, wherever, at whatever the distance you want to define. You can define in a short here also. You can define long also. You can define all. So these pipelines will be run on your tools only. So if I go for same MLOps, same thing, same thing. Okay, same thing. If you see, so we also do the same thing in MLOps also, but here is the data is the raw material for your application. Code is the raw material. Here, which one? You're planning and you're doing code. Which code? Java code, Python code, .NET code, Angular, okay, React Node. So this code is the source. But here for your ML model, which is the source? Data is the source. Data is the source. You need to understand this difference in MLOps and DevOps. If I take the same application with my DevOps, my application is running right now. Let's say my application is running right now. Inside my application, what I want something to be run. Which one? My model. Which model? A recommendation model or any model. Okay, a prediction. It has to do some prediction, some sort of prediction, sort of prediction. Example, we will take Amazon. Example, we will take Amazon. So this is your Amazon app. Okay, this is your Amazon app which you are doing everyday shopping, right? So you are a user, you are a user, you are here and you have access this one as your New Year sale is there on the 31st. You got ICICI credit card as 10% discount, something like that, and you wanted to buy something, a product. You wanted to buy a product. Okay, there are multiple products here. Let's say this is the product. So when you're selecting this product, there will be an information. So it will tell you that at what date, at what time it will deliver to your address. How quickly it is able to identify that. So you are giving your pin code while you are logging into your application, Amazon application. You given your pin code, your name, email address, phone number, and your address as well, like your pin code, and then your area, and then your colony, flat number, and all you are given. So it will accurately going to tell you that. So tomorrow at 8 p.m. or 8 a.m. or 10 a.m. to 7 p.m., this product will be able to deliver to you. So Amazon is not a small thing, right? They have big inventory, a very big inventory, right? They have very big inventory. So how quickly? So we don't know as a your human being. If I give the same task to you, this product maybe have 100 items. Let's say you have 100 items at the store, and there are multiple people coming to your application. So how do you going to analyze that this is a store? From this store to deliver this person address, how much distance, uh, and what is the time taking process, and then how can I promise him that in this given period of time I can deliver it. If you go back to 5 years back or 6 years back, take it as a like 7 years back, do you have this option? So they'll going to give you as per the pin code kind of a rule thing, a rule based kind of engine. So they're simply giving you one number, like next week we will be going to deliver you. For that you need to subscribe for the prime thing, like that. But now it is not like that. Simply telling you, even though you are free or a prime, it will tell you that how this recommendation model is running. Now this application is handled by the DevOps engineer. Okay, but what about this model? Who is doing this? How this model is reacting immediately whenever you select the product? immediately it will react to you that I'll going to deliver this. There is no fake promises. It's accurately going to predict to you. And the product also is going to deliver in the same time. So this is where a model will run similar like that. There are multiple models are running in Amazon. Okay. So by checking all these things. So for this example, you have entered some username, password, pin code, your all the information you have entered. In order to develop this, in order to develop this, I need to collect the same kind of data of multiple users. I need to I need to collect the same this user kind of data. So that's where the EDA, okay, you will be collecting and then doing the EDA, exploratory data analysis, which are all the things are important and which are all the things are not important. So nothing but data collection. After you're collecting the data, then do your exploratory data analysis. Okay. So that could be a different things. You are scraping the data, you're buying the data, or you are getting from your internal sources, or you're getting from external API sources. So whatever it is, you're getting them. Similar like here in the plan and code, you're getting them and doing this kind of task here. And then you're preparing the data. And then you go for model development. So you are selecting a 3 4 algorithms for one of your problem statement. Like last time I have shown you, right? 3 algorithms I took for one problem statement. I would like to test and do an experiment which one is going to work perfectly. Similar way, I'll be going to do same thing in this stage. In this stage. And then I do a lot of iterations. I'll be not conclude that in single iteration. I'll do multiple iterations on the experiment. So that is called fine tuning, hyperparameters tuning. Okay. Then you evaluate the metrics and all. And then I will do a kind of review and then I'll deploy that model. So deploying the model, where you will deploy, you'll going to deploy into your application only. So here you will be deploying. Here you will deploy. Here you will be deploying. So here this model is running. So let's say this is a recommendation model. Okay. So that is recommending the second products. And this is a prediction model, which is predicting you an exact date. I'm giving this product to you like this. So this model is deployed in this. Now, how this application and models together will collaborate and work. That is also important. Okay. And you, when you deploy, how you're deploying exactly. You're deploying as a container, you're deploying directly as an artifact, then your backend is loading that and then communicating with the front end. Fine feature engineering and no, both are not same, different. Feature engineering is different and fine tuning is different. Okay. So when you deployed here, so here your backend system is working on this. So are you directly loading this model directly into your front end or in between any API will be involved with your backend system? Yes, an API will be involved with your backend system and then you will communicate with your front end system. Okay, so when user is communicating with the front end, so now I'll tell you that application terminologies also. When you're communicating with the front end and this request will come to this model, right? Will come to this model, then we call inference. That is your request is coming to the model to do prediction. And then the response will be generated and immediately it will give it at your display. Okay. And this response is this model is running, this how accurately this is running, how many seconds it is giving you response, and how much it is consuming, is the load is high and low. All this kind of stats you are monitoring with the monitoring thing. Monitoring thing. So when you are monitoring, you got to know that, hey, this guy is from a new location. He went into a remote location where the pin code was defined, but the address was not present inside the Amazon. Then this address is not present. This model don't know about this address. Then how this model can tell you this guy that I'll going to deliver in this given time period? No, how? So that time it will take a common decision based on the analysis. It will give you a common decision, then it will give you a common prediction. Which if is not sure about something, then it will give you one response. Then later, based on your address is not there, then the team will be messaging you that. So this is how business functionality will work. You take same thing on the Uber also. You take same thing on the Rapido and other taxi booking things also. They connect the same Google Maps API to their application and they'll run their models, machine learning models on top of it. Yes, application is a front end and back end, same like the application, and they connect this one to the Google API, Google Maps API, and the maps will be loading here. On top of that, they are running the machine learning models. So at which location you are and how which one is available there. So there's lot of engineering is there. So these are all into MLOps, LLMOps, AIOps. So now I need to understand in depth this terminologies. Okay. So when you are unknown about this Amazon model is not known about your location, then it will take this data and keep it in a separate storage where it will collect. We call feedback also, and otherwise we call a drift thing. Okay. So here this data after a 1 week period time, the team will look at this. How much difference is there? Whatever the actual data they have and whatever the real time data it is coming, how much drift is happening in between, drift, the difference. Based on that, they will again evaluate this one, and then they will retrain your model. Then they will retrain your model, and again they follow the same life cycle, right? Same life cycle. They will again go to deploy. Similar way like your version. Here also you will follow the same version 1, version 2, version 3, version 4. Like in the last lab I have shown you, right? Version 1, version 2, version 3, version. Similar way, we also follow the same kind of versions to identify the model and deploying the model. We will deploy this model. It is not something like once you deploy the model and it will work for 6 months. No. The performance will be degraded. You have to always do often run every week a retraining process. At least in a month twice, or at least per month one time. Whatever your data based on your huge data or small data as per your customers. So if you're not do retraining, if you're not focused on your model that you left like that once you're deployed, your application can be work like that. Once you deploy your application without a problem, your application can work at least 20 days. Without a single problem, it can run 15 to 20 days. Can also be 30 days without a single raising problem. If you go with a normal uh, vibe coding applications where some 20 or 100 users are accessing, there will be no problem at all, right? When you go big applications also, hardly it is 10 days. Once you deploy, you can take relax. But model is not like that. Because because of this, see, I'm deciding my business. With this, I'm solving the business problem. How much application is important, similar way my model also is important. So that is the focus. So that much importance it is there inside the business side. Okay. Which is visible at the front end side, but the back end side internally in the application there are multiple models will run, like your search, where your search is also giving you a recommendation. When you're searching some keywords, automatically it will give you a recommendation based on your pattern. Okay. So like this, there are many models based on the problem statement. We will be going to discuss in deeper with each problem statement, how to collect the data, where to collect the data, how to scrape the data sometimes also officially. So you should not be do unofficially. You cannot scrape, otherwise you will be caught by the big companies. So that is not best practice also. Scraping in the sense, I went to a Flipkart example. I went to a Flipkart. I would like to build same Flipkart kind of application. I want this product details. I want same copy of this kind of thing or this data. How can I get it? This is called web scraping. Okay, you will going to scrape all this data to your local or to your storage site or you into your DB. Okay, so that is scraping. Okay, so similar way you will be collecting all the data. So collection of data involving many methods. Module wise we will discuss. You're collecting from different sources also involve many ways. Okay, so where, what, how you should connect, how your company also behaves in the collecting of data. Does it your company involving officially to take some licenses, or your company can be buy it, or your company is collecting from the free sources, and where you're going to keep it, that is also matter, and how your data engineering team is going to work on it. So we will discuss all this as the first module, but once we have the fundamentals of understanding on this process. Okay. Now, yes, I got some uh, good clarity of how this is happening. Means once my model served into an application and while it is doing inference, so I understand some technical terminologies here, comparing with the DevOps cycle. Anyone having any doubt here? You can use hand raising option. All good. Okay. Now I understand this flow. By going forward, we will understand in more deeper of each phase, not stage, each phase. We talk in the phases wise, not in the stages wise. Inside the phase, there will be a stages again. Inside a phase, there will be a stages. So, okay. So let me go to the application side. Okay. Now this is an application. So we usually call three-tier architecture, two-tier architecture like this, right? What this application, any application you take, we have web application, Android application, desktop applications like this, tablet applications also there. Okay, different applications in different category. Gaming side, uh, uh, this shopping, this retail side, and also medical pharma side. So different category applications also there. Okay, is all going to be a same strategy? No, but application development will be in single tier, two tier, three tier, n tier. You need to understand that. Okay, why I'm telling? Because you will be directly dealing with the front end thing sometimes. I'll tell you. So single tier or one tier. Okay. So when you have a static application, so this application is having a code in your GitHub. So you have a GitHub here. So this is a GitHub. Here you have a code, a file of any Java code or anything. Okay, you have it here, this one, and you directly deploy this code into some platform. Which platform, sir? GitHub Pages. GitHub Pages. And the second thing is S3. Third thing is your Google Drive also. You can do that as well. Okay, any storage things, your GCS, blob storage in Azure. Okay, so wherever it is available, you can deploy this. So what happens? Static applications means there will be no dynamic actions. There will be no dynamic actions. What static in the sense, you will be only seeing the normal page we used to call sometimes in the uh, digital marketing called landing pages. Landing pages, right? So whenever you go to any Shopify websites, or you're going to uh, some very normal shops in the Google, right? This session will be uploaded in YouTube. Yes, 3 days sessions will be only uploaded into the YouTube. After that, all are regular classes, and the link also going to be changed. Who are not enrolled, they won't get the link. I think all are enrolled. Only I can see 2, 3 persons are not. That's it. Rajkumar, the summary of the MLOps, DevOps, develop involved in building and refining machine learning models, data prepare the data training, including cleaning and processing EDA. Yes, the same thing what we have learned here. So it is going to catch all your insights, whatever you collected the data. First, you need to have the data and then do analysis, whatever you need, whatever you not need, then find a pattern and then go for and keep it at your where in feature store. From there, you send it to your ingesting again to the training process. We will all see this process. It's not like Google definitions will not make us more educate on the real time process. Real time process will involve many things. If I tell you about the normalization, outliners, fixing, so these are all the also matter in a notebook. MLOps guy is the guy who is going to convert notebook thing into the Python script. Okay, so that is the difference. Okay, my application is deployed in somewhere, so there is a complete static thing. Static thing in the sense there will be no thing that you are going to log in, do sign up, or do setting up your password. No, nothing will be not there. Okay, so you can write it down in any language, this static application. And our MLOps engineer versus ML engineer role same, or see, there are some roles will be different slightly, not complete. ML engineer can be also MLOps engineer. MLOps engineer also can be ML engineer. In according to your company and your team responsibilities that you're taking care. So ML engineers mostly put their all efforts into the model development side, model training part, and they're trying to find out a good results by doing an experiment. So in that cases, MLOps also going to be involved in it. So both are same, not different. But at some point, to get a wider work, so they will be defining the scope separately. So when you have a ML engineering team separately, then MLOps engineering team is also separate, who is only concentrating on infra, pipeline runnings, deployment, production side SRE, monitoring, retraining process, all this collaborating with the ML engineers. Okay. So if there is no MLOps, there is no ML team or MLOps team, then the only one guy is act like they are the one who do it the research and development side, who also do it the training side, who also do it the deployment side, who also do it the monitoring side. like a full stack. Okay. So if you are with the startup company, then you are the one everything. If you are at the big companies, very broader models and broad teams are there, and that scope is defined separately. Yeah. Okay. Now this application was deployed and I'm not having anything. Okay. So it is just a normal thing. But let's say this is a chatbot. This is a chatbot. So in this, I can just invoke any one API key, GPT API key. Then it can act. It will send to GPT and GPT will respond back to this. So this is a static one, nothing else. There is no much hard work needed for this. You can deploy it S3 also, something like this. When you have two tier things, where your front end will be there, where your front end will be there, and you also have your business logic. You also have your business logic, or you directly have any data, any database. Okay, any database. Okay. So you just telling to this one or telling to this one. I'm just telling or. Okay. So this is a two tier. Two tier. Your request will come to this one. How it will come, sir? So here there will be a web server which is called Apache, Nginx, all these things. Okay. It will come to this one and it will go to process business logic and give you a response back. Okay. Or you are storing that into your data site. And if you have three things like your front end, your business logic, and data layer, three tier, data layer, business logic, and you have your web service or front end side. Okay. So here it will be more like this, more like this. Here your API is also involved to communicate in between. Okay. So this is a three tier. And what is entire? Entire are nothing but microservices. Microservices. Now, wherever you see, everywhere is the microservices. Okay. Microservices are many things. Okay. I'll tell you. I'll tell you. So what is monolithic and microservices? Why we need to learn? We need to learn this. We have to. Because these are all the concepts that every day you're gonna discuss with your team, development team. If you are on a Scrum meeting, development team will join, your data science team will join, your machine learning, data engineering team will, everyone will be joined if you're under one Scrum. Everyone will give their updates, and there will be interdependency on it. Then how you will understand all those things? You should like if you're not know, if you know also, just please bear with me and listen. If you don't know, just please concentrate on this. Microservices and monolithic. There are two terminologies. Okay. Microservice and monolithic. What is monolithic and what is microservices? In a simple layman term, I'll be going to give you an example. Let's take your Linux server and let's take your Windows mission in your system. Okay, this is my Windows mission. In my Windows mission, when I went to update section, I got some driver update or I got something security update. When you got security update, your Windows system will tell you that you have to do restart. Otherwise, it won't work. It will tell you directly to you. Or you install any application which is also including your driver installation, then it will simply tell you that in order to reflect those changes in your system, you must be restarted. You should restart what? Entire system. Should restart what? Entire system. Then only it will reflect. So if you're doing an important work, then you got a break in between, right? You cannot only directly restart the specific service what you have updated. So it is disturbing your entire system in the Windows. So that is what monolithic is it. Okay, monolithic. And there are many legacy applications. Legacy means old. Legacy means old. Okay, old uh, designed application are there in the data centers on-prem. On-prem means data centers. Data centers. How the data center will look like this. Data centers. We're also going to discuss on the data centers point. Okay, because nowadays not everyone is moving towards the cloud GPUs. Some companies they're setting up their own GPUs. Actually, how they are going for their own GPUs, or they're just taking a lease some cluster of servers also sometimes. Okay, for their normal POC, they can't put all the money at the cloud side also. You single two servers are enough actually to do some kind of a small POC. Why do you go for a cloud actually when your cloud is not at your company? So they ask system admin teams to create one uh, this one with the tools at the on-premises side. Okay, so these are all the data centers. You can see these data centers. So these are called rack servers. These are all called rack servers. So inside these racks, all the servers will be there. Similar, your CPU, GPU, TPU also same. In a data center, this is how it will work. Your Amazon also is working on this data centers only. Your Azure is working on this data centers only. Your GCP is working on this data centers only. You take this Oracle, okay, Alibaba, all these clouds are working the same data centers. Your banking application, everything is working on in a server, in a data centers. Okay. So these applications was deployed on on-prem. On-prem means the data center, physical data center, whose company is managing on their own. Okay. Monolithic means which you cannot update a single thing independently. Let's say I have here this Flipkart. Okay. Here I have login service. I have cart service. I have become seller service, and I have this product catalog here. I have search service here also. Okay. And I have payment service also. This login service, request OTP service, all these functionalities are there inside, right? Which will work inside this application. Let's say developer did a small fix on this login side. When they did a small fix on the login side, they wanted to deploy that. When they are deploying, this entire application will be down. Not 1 or 2 minutes like that. There is a process also. So there is a process also. And the deployment side, we will see. So when you're deploying this, if something you cannot directly update this only one change. You have to entirely deploy the application, not only this code change. How to again deploy entire code change. So that is where it called monolithic. So when your monolithic is called, then you can call it as monorepo, because in your GitHub only single repository. In single repository everything will be there. Sometimes some other services will be in other separate repositories, but whenever you call monorepo also, everything will be in the single repository for the monolithic applications. You'll be deploying this single repository with a single pipeline. When you come to the microservices, let's say it is a Linux server. Let's say it's a Linux server. In Linux server, you can update a specific update separately and you can restart it separately. You don't need to do an entire system restart or shut down and start it. So in the microservices case, what happens? You can deploy this login change separately without disturbing this cart or without disturbing this become seller. Everything will work parallelly and you can only update this change. So that is the beauty of the microservices, and right now everything is microservices. everything. We take any application, everything is a microservices only. Now, few companies, they are migrating their applications from the on-prem to the cloud side by doing containerization. Because that is so important, containerization. So where they are doing deployments and all, they are deploying over the Kubernetes. And if you see, Kubernetes are coming up with the new version, actually 1.35, which is they're including AI/ML capabilities also in it. Okay. So Kubernetes 1.35, which is last December it was deployed, and it is having good features actually. So while it is running only, you can change the resources. Previously, it is not like that. Once you have changed memory and CPU, it should be restarted. But now you can lively do that. So that time it will won't affect anything. So it's evolving more. Okay. So you can read this document. So there are many changes they bought in it actually. Ingress controller gone and API gateway came now, and you can use them. And this GA was there, so which is this alpha features and the Kubernetes. We will discuss all this. What capabilities they're bringing up into this. So all these microservices are deployed where? It is deployed on the Kubernetes only, sir. And what servers, sir? GPU, CPU servers only. Again, okay. All are GPU, CPU servers only. Not no notebook, no VS Code. Everything will be going to be deployed here only. Monolithic means depends and update on a single service. Microservices means parallel process. Is this correct? Yes. Parallel process in sense these are decoupled. There is a relation between these two. These two will be work together. These two will be work together, but these two will be communicate together. But the problem is, sorry, the difference is you wanted to update this code. You can separately update this code. You will be not disturbing this one. This will work like as it is. But in the monolithic, this is the not the case. If you update in this one will be disturbed. Okay. You can separately handle, do deployment, do modifications, whatever, without disturbing your neighbor service. So that is microservices. But in monolithic, it is not like that. You want to update one thing, then all services should be down and up. One more time. Like this. Yes, monolithic is a tightly coupled and microservices are loosely coupled or decoupled. Yes, in microservices, what happens? You have this one, right? So this is a service, like let's say this is a payment service, or let's say this is the order service, or let's say this is the account service. Okay. You have each one separate repository, and each repository will have separate pipeline, and each repository will have separate pipelines, and each one is going to run as a one pod, one container, one pod. And how this is going to communicate, sir? Between this APIs and pub sub topics, SQS. So in general, how many models will be there in the company? So more than 100 models. If it's a big company, like if you take Amazon or Netflix like that, they'll be every day deploying more than 50, 100 models actually. So if you take a single a normal Spotify or anything like your kind of a banking application or a your insurance kind of applications, uh, they itself they do 20, 30 plus models. If you go to any vehicle, this bullet or this insurance claiming, right? They do this separate applications. Okay, so there itself they are running 20 plus models nowadays. Okay, various normal applications. So big companies are running more than 100 models actually. So yeah, one microservice to another microservice you wanted to communicate in a sequence process, then you can use SQS. And to communicate with your system business logic and the services, you can use API. Okay, you can use communicating purpose. So in a queuing purpose to one service to another service. So these are all the microservices. Do we really need to know? Just theoretical knowledge is enough. We are not going to put our hand in it. We are not developing. We are not developing. Developers are there. But our job is deploying. Whose job it is deploying? DevOps engineer job, not our job. MLOps job, your model job. Why you are again discussing on? Sometimes it is not always your model problem. Your model is depending with multiple other services also. When an incident is raised at your production side, okay, there could be a problem from the application side also. There could be a problem from your model side also. You need to find it out. It's not sure short thing. The model is only the problem. No, you have to do debugging. Okay, when some incident happen, itself it is going to tell you that the performance is degraded. So why it is degraded? Not only because of the data, there's multiple drifts also happens. Okay, so these are all just for to understand the system. I'm telling this, okay, because these are all needed for us to understand the system. So this is the microservices, okay, and all these are going to run on the Kubernetes, sir. Okay, it's all running on the Kubernetes. Fine. Now I got some good idea of which applications are there. Okay. Now there are some protocols. There are some protocols. You need to understand the networking process also. For feature store, what is the role of MLOps? For the feature stores, yeah, it is your thing. Uh, After you're collecting data and once the data is EDA is done, you will be also sometimes part of EDA also. Once the EDA is done and you have a fine grained data and you should place into the feature store. It's up to you which platform you want to go for Feast, you want to go for any cloud native services, you can go for it. So that is your job to develop a pipeline to put that data after the data science engineer or your data engineering team is done. So MLOps engineer's job is to keep ready a pipeline to push that data into some place. That is your job. So which place, whatever available in your platform, you can choose that place and put it over there. And then again, you need to develop one more automation or one more connectivity from the feature stores to you want to ingest to the training process. You need to ingest to the training process side. Okay. So that side also it's your job only. No one will not do. Data science engineer is a developer. He will not develop any pipeline for you. He will always purely on a notebook. Okay. And who will do that? ML engineer, MLOps engineer only. You have to do that. It's our job. Data engineering team will do that? No. They will completely they also do the same thing. So they'll write entire repository nicely, everything they'll develop, whatever. If you give any tool like Airflow kind of tools, they will do everything on it. They will configure everything on it. If whatever they're in their hand, so they can do. But other than that, they will simply give it to you that it's your job to do because you have a better idea than them. In their part, they have a very great ideas, and you don't have idea. Okay, so this is a kind of a cross-functional collaborating. So we should not confuse of which responsibility I have to take, which not. It's not like that. At company already the scope is divided. We should not worry about that. We will get to know which is our part and which is not our part. So there's a big confusion between data science, machine learning engineer, and data engineering team. In some companies, all together will work actually. Only data engineering team also will focus on the machine learning also. They just Go for the some regression model and testing with the, because it's a small thing, small model. It's fine. For that, no need of ML engineer separately. It's they will give a responsibility to data engineering team. Just please explore and do it. So they will do it. Okay. Now, yes, I understand that here. So we will be going to keep all this data and all. So we'll learn that about the data collection part. Okay. So application part is fine. Now I have, there's a communication. How the communications will be happen. Okay. Let's say you have this application. Every application inside you will be running any model, then that will be having one endpoint. How it will be communicating each application in each application, everything will be communicated through the endpoints. There is no IP addresses, endpoints. Okay, endpoints will be there with the endpoints only. If you want to do an inference, also endpoint. If you want to do or load artifact into the fast API endpoint, okay, you will taking that endpoint and putting there. You wanted to keep all the models in somewhere to communicate, then you'll keep an endpoints. Endpoints will be the thing. But at the DevOps side, IP addresses are the things. IP addresses and DNS. Okay. So here it's internally your models will be and your other things, your data points. Okay. All these are going to connect with the endpoints. Okay. Now this is a server. Inside this server, my application is running. Inside this server, my application is running. So this is my app. Okay. This is my app. So this is a server. So this server will be having one DNS. I'm just giving you this knowledge. DNS. Okay. DNS is there. So this DNS is something like this. www.abc.com. Okay. So this will be communicated from your laptop. So these are all fundamentals, sir. We need to know. So many people don't know. Okay. At least this is a troubleshooting. This all the information will be going to help you in a troubleshooting. So when you wanted to access this one to this one, and there's a process will be involved here. So this is called OSI layers. This is called OSI layers. So when you're connecting your LAN cable or your Wi-Fi, so which is called physical layer. Physical layer. And this is going to be a data link layer. Okay, data layer, sorry. Data layer. And then it is going to be a network layer. And then it is going to be a transport layer. And then it will be go to the session layer, session layer, and then presentation layer, and then go to the application layer where your protocols will work. Okay, this is about applications only. Don't think this all at the models. Okay, at the application sites. Here, when you're requesting anything, you are searching right here, so it will come like this. It will hit here. Your HTTP, HTTPS, and your TCP and UDP protocols are involved here. Okay, so this is the how the communications will be happen. Once it is enter and it will do here and it will display here and it will come back to the same way to you. So this is how it will involve. So this is called OSI layers, how the network communication will be happen, and this is a DNS. Most of the people already know what is DNS. So behind this, there will be IP address will be working. Everything is IP address. Everything will be the IP address only. Why I again telling this all? If you ask me a straightforward question, these are all going to help you in your AI ops or at your AI agents. How? This is the thing, right? You're developing AI ops for what? Your model monitoring and finding out the root cause, and your application monitoring and finding out the root cause, and your infra monitoring and finding out the root cause, and giving you solutions. You should have all this understanding, right? So if I don't have all this understanding, then I don't know TCP UDP, but my AIOps LLM was telling that hey, there is a TCP connection was missed. If you don't understand what is TCP, then what solution you going to implement? Your agent is telling that something, oh, there is a something happen on the TCP, you must do this configuration. Or because of heap memory things, it's continuously that a thread process gone, something like it is told you. You're not getting it. You're not getting it. Taking the same thing and again asking to the chat GPT that what is this and teach me and then I will do the implementation. No, it won't help you. Okay, because you will be in a call with the team members like this, and people will look at you, and at that time if you use ChatGPT to teach me that, you're not an engineer, everyone will judge you that time. So these are the basics that we need to know, very basics. I'm not telling that this is going to be help in the MLOps is on the ML side. Okay, it is going to be an AI side, LLM side. Okay, you should understand because ultimately all your things are going to be with the application only, with your network only. Sometimes your model will not communicate properly, or there might be VPN issue, or there might be network issue, connection thread issues. How you will troubleshoot this one? So whom you will give this responsibility? Whom you will give this responsibility? You should do, right? You should inspect your on your own, and then you can ask somebody that, oh, I have inspected these things, and then you go to system admin team or an IT team or a cloud engineer team or network team, security team. Oh, this has happened. Then can you please fix this up? There are some small, minute things can solve your problem. For that, no need of raising a request to the other team, right? So that is the that will prove your efficiency in the team, in the company, actually. So these are all the fundamentals that we need to understand. Okay. Okay. I got some good understanding on this. I hope. Like anyone having any question or a doubt on this part? I will give the document. I will give everything whatever I'm teaching. I'll give a notes. A good note, Notion notes like my syllabus. You cannot copy it. You cannot download it, but you will be having lifetime access to this website. Okay. Cool. Now, yeah. Okay. At the network part, okay. And there are some protocols as well. Okay. There are some protocols as well. So what protocols are? Yes, as I said, like HTTP, HTTPS, okay, HTTP, HTTPS, SSH. Will you do SSH to a GPS server? Yes, not only notebook. Okay, HTTPS and DNS, TCP, UDP, all these are there. All these are there. So when you are implementing any load balancer, these are all the matters. Okay, load balancers at your model sites. Okay. So these are all the protocols that will work, and each protocol will be having one port number, one port number. Okay, one port number 443. and 80 like this. One port number. Okay. So each port number will work actually. So we have 65,536 port number, something like that. That is the range from 0 to this one. So in this port numbers only, the network will be communicated. In observability, what is the role of MLOps? In observability, there is no role of MLOps. Yes, there is a thing. I'll tell you in the last how it will be. For retrain, we will use same pipeline or a different pipeline. For retrain, it will be a different pipeline, not the same pipeline. Same pipeline, you can apply the logics also, like in a way. If you have a single pipeline, let's say, so you're taking a batch data from here, okay, batch data from here, and you're doing training process. So that is fine. You can use the same pipeline, but you give options, parameters. You want to do retrain. So when you're doing retrain, you take data from some other place. Okay. So when you click on this retrain option, then the pipeline behaves like a retrain. It's your wish. You want to use single pipeline or a different pipeline for retrain. Okay. I can use single pipeline with the two different stages, train and retrain and test and split. Okay. Like evaluation kind of thing. I can use like this kind of stages in the single pipeline. Then I can write the stages here. So it will work according to my stages. Like this all I can define, or like this with the parameters, or like this also I can define. It's up to understanding of the platform in a company. Okay. You need to analyze of if I develop like this, it will be a good automation, or if I develop in a something other way, it will be good. Eventually you will be evaluated automatically. When you develop a single pipeline, if you find a problem, simply you'll go for another pipeline. If it is working for you, you will enhance the same pipeline for the better results. Simple. So like this, we can go for it. Okay. So these are all the some of the protocols that are present. Okay. And now, okay, as of now, I got a little good understanding on this. Let's also understand application side. Now you have an application and you have a source code. So this is a source code. Source code means your Java code and all. And this is your running application. Running application. You are running this application like this. In between, there is a called artifact. Artifact. Okay. So this artifact will be having all your source codes, because this source code is going to compiled. If you know the DevOps, you will be able to understand very better. After the compile, it will generate this artifact. This artifact you're going to executing in a container on in a server. Similar way for your model also, not for the LLM, for the model. For your LLM, you have to develop your applications. Here, artifact dot pickle oblib onn like this, or .h5. All this you are going to develop an artifact, and then you are going to serve them into the, after registry, you are going to serve them into a server. Okay, into a server like this, into a server. So this is how your model. So same, similar like that. You can understand here. Same principles. Again, no difference. But here the main part is data, but above is the main part is code. Okay. And again, these two will work together at the end of the product. The end of the product, they work together only. So this is the uh, understanding we should understand. Then while we are going with the labs, each phase we are going to develop will be very very important and give you more understanding on these parts. Okay, so why we have to go for which artifact, why only that one, why this algorithm only we have to select, and what this metrics only we have to, and what sort of data will be, and how things will be coming up from your BA data science engineer, and then you are doing all your data kind of activities, and then going for the training process, retraining process, fine tuning process, all we will discuss. Okay, then we'll go to the similar way to the LLM, then we'll go to similar way to the AIOps, and then similar way to the agents as well. Similar way how you have your application for your models, you are not doing any applications. Okay, your model is only the model, you're deploying the model into an application, into an application. Okay. S- okay, because this is going to be work inside my application, and that will generate a response for me. Okay, that will generate a response for me. Now here I can understand, if I keep LLM, will that model and LLM will do the same functionality? Okay, I have a running application here, and I have a user, and I have a user. The user is here. User came and asking here, he selected a product. Then immediately this application giving at what date I can deliver you. Instead the model, if you keep LLM, will it do the same thing to you? Can anyone answer? Will it do the same thing to you? So I am keeping the model here. I'm keeping the ML model. ML model is doing the prediction, right? At what date I can give it to you? Will LLM also do the same thing to you? So LLM, yes, that is right, Amit. Your model is mostly on your math, numbers, regressions, linears, okay? That will calculate all these things, and then it'll give you probability. But at your LLM, it will process, because I was keep on telling to many people that is every ML model is an LLM? Is every LLM is an ML model? Okay. So ML model can be an LLM, but not every LLM is not be an ML model. Let's try to understand it. Okay. If I say about the ML model, my ML model will be on the probability. Okay. And this is going to train on your own data, whatever you're giving to it. But LLM is the same model, but it is trained on over the period of time with billion parameters. Trained on with the billion parameters, then it is having the a transformer architecture within it. Okay, where it can be on the embeddings, where it can be generate the tokens, and then it will process, and then it will generate the new idea to it, to you, or whatever you're querying. So it is new generation. Okay, it will generate the new thing to you based on your analysis and the processing of whatever you do query, because it is already trained on it, a text, a video, image, whatever you take. Okay, there's tokenization embeddings in the LLM. But when you go to the ML side, you will do with an algorithm. That algorithm you convert into the model. That model will only give you the new pattern. Okay, whatever you give, based on it is whatever it got trained, it will give you the new pattern answer. But LLM will understand that, it will process, will do analysis, and then it will give you this one. Okay. So LLM could be a multiple things they involved and they generate one LLM. Behind the engineering of LLM, they will do multiple things. Okay. So you take a bird. Okay. Bird model, cat bush kind of things. Okay. You take them as a text things and then train them with a lot of data and then apply the architecture with that. And then it is converting as an LLM. But not every LLM is a ML model. So that is the difference. Now what happens if you keep the LLM here? LLM will take a little seconds of time, then it will generate the new text to you. Not like this number. Okay. So like last time in the lab we have seen, right, that values. Okay. So LLM will do a new generation, new text generations, whatever you are doing. Like you are also seeing image generations, video generations and all, right? Behind the case, LLMs are working. So, but I think AI agent can do if it is can be given access to an ML model, let's say regression model as a tool which agent can call. Agents is having wider scope. That's what I was telling. Agents is having a wide scope wherever, whatever you wanted to keep in it. So it will pull whatever data you wanted to pull from any specific platform or a tool or a area, then it will pull it on behalf of your action and then it will put into your destination. That capabilities agents are having. Okay. Agent can do that thing to you. It is mixture, everything it can do on behalf of your actions. But developing an agent is involving a lot of architecture and engineering. It's not simple that as easy we are discussing. It is having many components if you do. Okay. Yeah. So here my model is running on this. Okay. Here my model is running on this and my model is serving, right? Okay. LLM you can keep for your chat application kind of thing. I can say, can you help what is parameters and the transformers? Okay. See, if you ask me parameters are something like how your ML model is getting trained and learning the data from whatever you're providing. So how you wanted to be learn it. So that is what you are defining with it. Okay. Like your linear regression, weight and bias. If you're going with the neural networks, so millions of weight you have to apply it over there. If it is a LLM, then you have to, with the billions of parameters, it has to train. Okay. So that is called parameters. When you ask me something similar way, like transformers were like it will read the text word by word, like by applying LSTM and RSS kind of models, old models. It will read all the words at once, then it will understand the context. Then it will understand the context, and then in a much faster way, and then it will generate the new thing for you, new generation. So that is the transformer architecture. Okay, transformer architecture is a neural network. So that will understand always a relationship between whatever the data it is using and the attention. So there's an attention mechanism also in it. We will discuss in the LLM. So there is attention mechanism, embeddings, all this with transformers. Whatever it is understanding the relationship of whatever the architecture you have designed based on the data you are providing, it will give it to you an output to you. So values we adjust during the training parameters. Yes, whenever you provide some data to train to a ML or LLM, You wanted to define how it has to learn. You want to control it. You want to tell it that, oh, this is the way, this is the limit. How you will tell to a model? To human, I can say, I can give a boundaries. But how can I tell to the ML or an LLM model? What boundaries I can have? What options I should select? Parameters are the things for us. So how many parameters you gave it to it? How much you want to define to a ML or LLM, that will take, and it will based on that, it will define their learning data or parameters, how it has to learn, and then it will adjust the parameters, whatever you adjust it, then it will generate the new things to you. We will see with the code blocks, and by running, by changing the parameters also. No hurry, will do, learn slowly. Okay, so parameters, something like a memory of the models. Okay, so memory of the models, you can just keep it like that. Now, yes, I understand that my LLM can understand this and it will do. Now on top of this entire thing, you can build AIOps. Now coming to the agent, if you place any agent here, lot of discussion this is. Okay, so if you're keeping any agent here, so this agent has to do some work for you. This agent has to do some work for you. Let's say you are queried something. Let's say you queried something and it is going to connect, by understanding the relationship, it is going to connect to your DB, SQL DB, then it will fetch back to you. Okay. Or if you say run it, then it will run like your copilot agent. Okay. It will creating a file system to you, right? In your thing. If you ask it, create a file, it will create simply. It will create simply for you. So this agent can do that. Because you're giving capabilities to this agent to do certain actions based on the relationship it is understanding and the context window. So ML is working on the algorithms and LLM based on the transformations architecture. Yes, right? Like parameter, word embeddings and attention mechanism, and agents based on the action and tools, agentic AI, like autonomous agents. Yes, that is correct. Agent tools like MCP. MCP is a model context protocol. Uh, Nowadays, MCP is everywhere because it is having very good value comparatively with your API. Let's say MCP is a protocol, yes, model context protocol. If you have your LLM, okay, your LLM need some data, or top of this LLM, you built an agent. By using this LLM, you built an agent, let's say. You built an agent. So this agent, whatever you are asking, it wanted to do it for you. Do it for you. Okay. You're asking to this one or this one. Okay. And this is going to connect. You should have one MCP client and server. So this is the server, MCP server. And if you have a client, and then this you can connect to this one, and you have here web, you have a database, you have an application, you have a other APIs. Okay. So these are all the tools you have. Okay. Web, data, and this is some uh, cloud, and this is GitHub. All this access you will provide to this MCP server. MCP server to your MCP server. And MCP server is very simple thing actually to configure. And you have a client here. So whenever you say to the LLM will, by using of client help, it will give it to MCP. MCP will go and do write, read data kind of actions. Then it will read for you or fetch for you. Then this output will come here and it will come here to here and it will analyze and it will give it back to you. If it is the agent you have configured, then it will give it to the agent. Agent will understand whatever the LLM is said and then it is going to selecting a tool, then it will execute. If you're using MCP itself to tell the LLM, hey, go and execute, then MCP is having the power to execute that, then it will execute in it. Then it will execute in it. Simple. It will do post. Okay. Or if you ask get, it will do get to you. So if you use the API, what happens? There is only one thing. Key is equal to value. Like that. Direct, straightforward. In API. You should define a schema, whatever you defined with that will only work accordingly. But at MCP, by your LLM context window, whatever you're saying to this MCP, by using these capabilities, it can do for you here. This is a model context protocol. It is working everywhere now in the industry. Not replacement. Don't use the statement. MCP is not the replacement of API. API is having its own capabilities and own things, and MCP is having its own capabilities and own thing. MCP is very better at your AIML workloads and AIML actions. API is application sites is good. The web application side. MCP is when you have LLMs and all. MCP is the perfect for you because in the API, let's say you connected API, to your LLM. You said something, then it will set something. It will go, it will fetch. What it will fetch? It will fetch here. It will come here, and it will leave it here. Your LLM is having an access to this one, whatever it is fetching the data, right? Will you able to maintain any backup here? Is this API is having any um, here you have a memory, but here you have any kind of a backup or a memory kind of thing. Simply you are fetching that and you're putting into LLM hand. If you're using this uh, from an Anthropic cloud, you're simply keeping all the data at his hand. If you're using MCP, you're retrieving from it here. Here you have something, then it is coming here, and here it will become. Okay, whatever the metadata it pulled. So somewhat is a security is applied. You have a third layer involved here between your actual thing and your LLM. Okay. In case of API, we write more code on client side, but if MCP, we write code on a server side and very less on the client side. Yes, it's a simple actually. I think 5 lines of code is enough at the client side to connect. And here you will write 10 lines of code will be enough for it with your node and all. Very easy because every use go for Git, go for Google, you go for Amazon. Everyone is already developed their MCPs. You can just use them directly into your own MCP server, and you can run this server on your Kubernetes. You should run MCP on your own, on your in-house only. You should use MCP in your in-house, not somebody is providing MCP. Who will be providing you MCP server? Who is the provider? Where? You should run your own thing. Like, okay, it is not that you're downloading cloud and configuring with normal configuration file and then you're connecting to your GitHub. No, at the companies you will run your own MCP server at your Kubernetes and then you give access to this and then you will connect all these connectors to it. So while you're connecting this all connectors to it, then you use your LLM. We will discuss all this. We will build our project also. So here can MC, yes, MCP code will be containerized separately in a single container, and you will be deploying the Kubernetes and say similar like you, however you are running your normal application pods, you will run the MCP similar way. Okay. Now it coming to the agent side. So if I say this agent, okay, nice. If I say this agent, but is this agent is going to be a single stack, or my LLM is going to be a single stack? My LLM should be distributed stack, and my agent should be also divided stack with the divided roles and controls. I should not give direct an agent with all the permissions. Let's say my agent is here. My agent is need to Rashekar, you are drawing something on my board. Just please stop it. I think you enabled pen. Uh, can you please check? Yeah. So my agent, okay, I should give an admin control to an admin user. Here I have an admin user, and I should give a control to the user only to select. I should give some control to the memory side. I should give some control to other platform side. So I should also have other control mechanism, least privileges control mechanism. Okay. Yes, I'm running an agent. That is good, fine. But there is an owner. This owner wants us to control this. Whether this guy is going to control with a code. This guy should control the agent with the code. Once you deployed and there is a owner is a non-technical guy. You should give control with a dashboard to this guy to do control this. This agent should not perform. This agent should be shut down like this. And you should say to the users that what level of agent capabilities he has to get in it. Ask mode, edit mode, read mode, plan mode, execution mode, like this. You need to set up a modes by a user perspective, or you have a tool perspective. Then user should select a tool, or if he user said that implement based on the analysis, then this is has to be have this capabilities based on the user or admin. Or you have a memory allocation that you are using any RAG systems, then your agents should collect a specific thing and then use like so agent will be involving in all these aspects. It's not only something I just written some code, SDK code, and in that I invoked LLM. That will work. It's not that so thing that we are getting a Google definition. It if you are building an agent, you build it for a purpose, right? A big purpose for it. You wanted to reduce a lot of human efforts on it. You take it on a observability side, you take it on a AIOps side, you take it on a ML side, you take it on a LLM. Okay. Always LLM inside the agents only. So agent can do a lot of work for you on behalf of your thing autonomously. So this is very important. To reach this point, we have to learn all this AI, MLOps, AIOps, and LLM, and then we can build a very good code agents, application agents, business agents, whatever KPI you are defining based on it, you can build your agents. Quite easy. So we are going to see the privileged sections of agents while doing the projects. Yes. So we can provide, let's say you and me are there, we both are engineers and you are a developer and I'm a platform guy. So for me, based on my user level, my agent should act something more, and based on your thing, my agent should act different. As of now, this kind of implementation was not there in the market. There is only subscription based there. Based on the user and the group level, agent should behave like this. Nobody is not defined it. Still in evaluation period only. Agents are not up to that maturity. Okay, for your developer, it has to work on a something like in this boundary only. For me, it has to work in something boundary only, like this. So still evaluating those kind of strategies are still evaluating, and they are doing a lot of brainstormings on it. When providers come into the picture, providers came, but people are not consuming it. Like chat GPT agents came. Do any one of you are trying? No, because they itself not even given a free also. They're directly in the first only they're charging to it. And you have N8 agents, N8 agent, which is somewhat free, but these are all plug and play things. And crew agents, which is the code. Crew is you can use, N8 you can use. Okay, if you go to this one, TLDR, TL draw agents, something like this. This is a MCP. If I design the TL draw, yes, this one. You can go for the new project and you can just define here. Already a lot of things are there. So if you select a texting in the first text you have selected here, and then you ask for the image, it's going to generate the image, and then you're asking to model select, then you're asking speech, something like this. You're just connecting to this one to this one, and you're connecting to this one to this one. Example, you said that generate the moon image. If I go and run this, it will start the workflow and it will trigger this one. It will generate an image here, and then it will go and generate a speech also here. It's a plug and play kind of agent things. So it's generated, and now it is generating the speech also. So you can configure website, speech, camera, and all this. So once one action is triggered, like people are showing on the YouTube like N8N, right? So this is an alternative to it. N8N is not enterprise level. It is not. This is also not enterprise level. Nobody believe in that platforms. It's a very high risky data is there. So you have very sensitive data, then you'll be risking on your own putting all the things on the N8N things. Okay, nobody will not give this handover to the third party services like that. Use. Oh, it's already done. I should play this one, not this one. So there are other orchestrators, agent orchestrators also there. They will they are giving you provider systems to you to integrate with your platforms actually.
Look up at the silent sentinel of the night, a world of stark contrasts where deep
It
shadows
is
cling
running.
to the edge.
Okay, it is so simple. Okay. Similar way, there are many other providers are there. What happens at your in your own company? In your own company, you have a Slack and all. Okay, you have a Slack and all or a Teams and all. Instead, the Copilot, you'll be using other chat agents. Chat agents. There are some providers. You'll be buying those chat agents and configuring on your own rack system. Configuring your own rack system. And then whenever a user asks anything, you will be going to your chat, you ask something about internal company details, then it will fetch from it from your Confluence or the GitHub or whatever you have information that you feed it to your chat agent, to this agent. Okay. So this is a system control system and orchestration system they are providing to. There are some companies selling it enterprise level. Then why is there such a huge hype in the market around tools like, so that is on the digital market side. Okay, not at enterprise levels. Digital marketers, what they want to automate their, if say for this course only I have run some ad. Okay, whenever you seen my ad, you said that I wanted to discuss on my WhatsApp, right? So I was manually replying to you. Instead that I wanted to automate. So what I'll connect to Zapier, and then Zapier I connect to my calendar. I also connected to my auto replies DM mechanism. Okay, then it automatically based on your whatever the query you did, so it will respond back to you. So I can connect multiple tools like that. So where it is going to log your information, your phone number, name, email address, everything, your profile name, and your link into my Excel sheet. How I can do connectors? What connectors I can use? A normal digital market guy, can he come into the Azure and he will create any logic app? No, he cannot do, right? So what is the service available for them? Kind of a Zapier tools. It's a very easy plug and play kind of tools. So that's where the WhatsApp automation tools, these are all they're selling outside, right? So because there are many members who don't know about the things and they will be using like this. But the engineer teams and enterprise teams will not depend on those kind of tools, because those uh, uh, those having the separate capabilities, and when you are working on the cloud side, your own development side is having a separate capabilities. Okay. So if you are looking forward to integrate Zapier at enterprise level, Zapier can work at enterprise level, but not N8N. At your personal projects, normal digital marketing things, yes, you can use them. Few startup companies have started using, but they're not finding a good value out of these things, because you should pay to them. While you're paying, you need return also, right? When you're not getting something a return, good return, then what is the use of your pouring your money on it? That is also very important. Nowadays, pouring money is going very high, okay, but they are not getting a good returns. We'll discuss all this in a coming classes. So I just wanted to give you all these fundamentals, and from tomorrow we will discuss on the prerequisites, installation of tools, and creating our accounts, whatever the accounts, and like GitHub, Kaggle, Hugging Face, Google Colab, and other Vast AI and other things also I will tell you, like inference API and all. And then we will start installing in our local system, setting up the local system with the VS Code, and setting up the local system with the Docker, and setting up the local system with the other like Docker MCP toolkit also, and other things we will discuss in a sequence wise. So for setup, I recommend you should use at least single. You have a laptop, then it is nice. Okay. If you have any, you're using any monitoring setup, since everyone is working, so please keep your tab or a mobile like this. If you're using mobile, then use a mobile here, mobile. And if it is a laptop, or this is a tablet, or if it is a your laptop, then it should be a monitor, and look at here and execute parallelly with me a lab. So you don't need to spend a separate time again after the class. So it will be very easy for you to understand and execute parallelly with me. So we will be sharing all the codes from the GitHub repositories only, and then you can start the same procedure whatever I'm doing by watching in the left side and doing at the monitor side. Any questions as of now, or any confusions? Any concerns? No questions? Yeah. Daily 1.5 hours sure pakka, and 2 hours is depends on our lab. So we will be doing lab, right? Some people will do fast and some people will be doing slow. So we should provide time to everyone. What is the size of the data? See, it's all probably, so probably it is will be around your 100 and like your same like your Docker image size, whatever your artifact size will be there. So in the MBs and the GB, similar way your pickle size also. Still any questions? System or laptop configuration, normal 8 GB RAM enough? Yes, 8 GB RAM is enough. And your graphic card should be at least 2 GB because you wanna do any local things. Okay. I'm using a Mac where few things are already installed, or so should we create a new virtual environment to install packages specifically for this course? No need. Mostly we go into Python and Python virtual environment is enough. Pip, done. Any questions? No, excited to move ahead. Thanks for the sessions. No questions. Yes, moving forward, you will get more questions actually. And yes, you should ask questions wherever you have doubt. Just stop me and ask me. Will clear that doubt only. Will go forward. Otherwise, it will remain same like that. And maybe I'll be in a flow and then I'll be forget. So it's better that and also in every class what is the agenda is like. So what I'll do first, in 2 hours of time, 30 minutes will be a complete theory giving you idea, focus, why, what, why the companies has to consider, and the problem and the solution with that. All these components will involve in a 30 minutes of theoretical explanation, and then a practical is always depends on 1 hour or more than 1 hour. Okay, it could be a less than 1 hour also. And then we will be having Q&A, and then every day I'll give you the new AI trend, what's going in market. We can all discuss what's happening. If you learn, you found something over the internet, and then tell me. Every day I'll find something new actually. I'll share it with you. Or if any article or a new document wherever I added in a new communities, so I'll be sharing that with you all. So this is the last 5 to 10 minutes we're gonna discuss. If there's no time, okay, we'll cover in the next day also. But every day there is a new news is coming on the AI trend side. Or sometimes it will be 3 days or 1 week new news will be coming up. So we'll discuss all the new AI trends accordingly. So I'll be giving you a list of these things. You can add over there. So dev community, you can go the Kaggle, you can go the Hacking Face, you can go to the Slack, Discord channels. There are many channels are there. So I'll be giving you those channel names and all. If you are familiar of using the Discord, then use the Discord. If you're familiar you're using a Slack, then use a Slack. Otherwise, Telegram is not at all helpful to you. Telegram is a lot of trash only. Dev communities are there. Some other web communities there. I'll be sharing. You can join over there. Yes, I'll be sharing Google Classroom. I think everyone already, for the new people who are don't know about the Google Classroom is a Google LMS. If you go here, you will find Google Classroom. Okay, when you click on this, Classroom will be open. Who are already enrolled, you will be having already invitation at your mail. Just join that class. Automatically, you will be joined into the class. And there you can see the classwork and you will find each topic under the topic, the classes. If you click on the class, you'll be able to see the video, notes, material, whatever required for that session. All things I will upload there after the class within 30 minutes of the class. After it is over 30 minutes, I will upload all the things over there. Cool. Thank you. Then we already reached the time. So thank you very much. And whoever new and not done enrollment, just please contact me on my WhatsApp. And we'll meet you tomorrow at the same time, 8 p.m. to 10 p.m. Thank you. Thank you, everyone.